Everyone, welcome to the machine learning class. In this video, we're going to be exploring the overfitting issue in the machine learning environment. So what is overfitting? Overfitting occurs when there's a complexity in the model. What I mean by complexity, I usually refer to the number of the features, number of the variables. If you have a high number of features, high number of variables, the model tend to be complex. Okay. And in such situations, the model does a very good job in the training data, but does a very poor job in the test data. So therefore, what it means is that it fails to generalize the naive examples, the unseen data sets. Okay, let's go to our own analogy that we have used before. Okay, let me just use the eraser here so that we get rid of it. All right, I think we're good here. All right. So in our common analogy that we've studied, there is a teacher, right? There's a teacher, and this teacher trains her students on the sample exam first, right? That means we call it training, right? Training stage, right? And then there is the real test here, okay? So this is the training set, this is the test set. So what is supposed to happen is that students should train themselves from the sample exam, and then they should feel confident, and they should go and take the real test, and they should do well on it. That's what's supposed to happen. So in the overfitting issue, overfitting concept, what is happening is that students are training themselves in a way that they memorize the questions, okay? They do not really study the real concepts, but they rather memorize it. So they think that they learned it well, because what happens is that when you study the sample test, you usually go back and test yourself on the train again, right? On the sample test again. That's how you test yourself, right? So if you're memorizing it, you don't realize that you haven't studied or you haven't learned well, because the only data that you have is the only set that you have is the sample, right? Sample question set. So you train first yourself on it first, and then you go back again. You test yourself on the sample test again, and when you do well, you think that what, I'm doing very good. I feel confident. I think I'm ready for the real test. So which was wrong? Because you have over memorized the things, you haven't learned the concepts well. What was supposed to happen is, instead of memorizing, you should be learning the real concepts and the solutions, so that you could do well on it. Okay. So to summarize, students do a very good job on the training questions, which is the sample questions. They basically tend to over memorize rather than learning the concepts. Therefore, they fail to generalize the new questions. When they go to real test, they fail it. Okay, that's what happens. So as human beings, we're basically, this is the machine, right? And this is the human brain, right? This part is the machine, and this part is the human brain. Okay, so basically in machine learning, what we're trying to create is that we are trying to make the machine learn the things just like human beings, right? In the artificial intelligence, that's in a very broad sense, that's what we're trying to do. All right. So let's think about a blind man, right? This blind man has never seen a car in his life, and he doesn't know what it looks like. He doesn't know what engine is. He doesn't know what transmission is. He doesn't know what wheel is, and so on and so forth. You name it. Okay? So to his world, the car is something that he has not been exposed at all, right? So what we're going to do is, okay, we'll call it our blind robot. Okay? At this point, he's a robot at this point, right? And what we're going to do is we're going to train him with a training set. Then we'll have him, we'll test him on the real test. Okay. So the problem is the definition of the problem that we have at this point is we're going to show him the cars, okay, and then we'll expect him to learn and label the cars in the future, right? We'll give him the first sample that we're going to give him in our training set is a brand new Mercedes, okay? And what he's doing is, okay, he's getting in the car and he's touching the wheel, the transmission, the dashboard, the AC, the sunroof, and so on and so forth. which has a lot of Mercedes, brand new Mercedes has a lot of features, right? All right. So that's what we've done. And then he's done with the first car. The second car is again brand new, let's say Audi. Okay. So again, this car has navigation, rear camera, and again AC, and he then cooled seats and so on and so forth. Again, a lot of features. Okay, which makes the car very complex, right? And the third is, let's say again, brand new Cadillac. Okay, which has again a lot of features, like AC, heating and cooling seats, transmission, autopilot, whatsoever, you name it. Okay, so again, a lot of features. All right. So, and we think that by exposing this man with a lot of cars like this, but I mean, all of them are brand new and they have a lot of features. So what will happen? Do we think that this car is learning the cars well? Do you think if we, give him a real test with a random car from the street, do you think that he will be able to label it well? Okay, let's just test it. Okay, after showing him all these brand new cars, all of a sudden in the test set you're showing him a 1955 Mercedes model. Okay, this is still a Mercedes, right? But then it's 1955. It doesn't have a lot of features just like this car does, right? This does not have the AC, this does not have the sunroof, this does not have the automatic transmission, this does not have heated and cooled seats, right? Therefore, what this man will do is this man will think that this is not a car, right? And given that this is a car, this is a car, right? This is not a car because he memorized the things. He did not generalize the things. Therefore, whenever he does not see the things that he thinks that it's supposed to be there, he mislabels it. All right? That's what happens in overfitting. You think that the non-important things are important. That's what makes the car, right? But in the actual case, the important feature that makes the car real car are wheel, right? Without wheel, the car does not walk. And the tires, right? And then the engine, transmission. There are only four or five, vitally important concepts that has to be, in the car. But AC does not make the car, or heated seats, they don't have to be there. So they are only, luxury, right? So we should not let the model mislead us in the concept of overfitting. We should not pay attention to those details which are really trivial. Okay, so that means in the long story short, we need to learn the things. Our model needs to learn the things in a way that it could be generalizable. It should be generalizable. All right. So complexity is the enemy of the generalization. All right here. Okay. So overfitting, what are the causes? The first one is the high complexity. That means too many features, okay? Too many variables, okay? Too many features or too many variables. That's what we call it, high complexity. Remember in the Mercedes case, these AC, navigation, and so on and so forth, a lot of features were there. And when the robot was learning those things, he automatically added a lot of features in the data, whether the car has an AC or not, whether the car is heated or not, whether the car has navigation, sunroof, and so on and so forth. The robot itself automatically created those variables by itself, and then that's what caused the high complexity, right? So that means too many features, or sometimes too few keys in the data set. If you have too few keys in the data set, that means the machine will not be able to learn the things well, because the machine will not be able to be exposed to diversity, right? The diversity. So in our case, the robot was not exposed to 1944, right? Or 1965 Toyota, right? The machine was not exposed to such things. That's why the things that the machine learned was misleading. All right. So high complexity almost means that there is a high number of features, variables in the data set, and The reason that I'm saying almost is, theoretically might be something else, but most of the time, high number of features or variables means high complexity. Our job in the overfitting issue is to reduce that complexity, right? So again, overfitting, if when we have too few cases, it's very hard to learn. If you only, give him like five cars and then, like Mercedes, Audi, and so on and so forth, there is a very little chance this machine will be exposed to, the older models. Therefore, it will become very hard to learn the reality, right? So how do we detect the overfitting? So what are the ways to detect and solve the problem? So the overfitting occurs when there is a complexity in the model. So whenever you have high number of features, this is a point where you should be very careful, right? This is you should be very concerned about the complexity of the model. If this is too complex, that means if you have too many number of variables, you need to find the ways to reduce those variables to be able to generalize. And then second thing is you're witnessing that the model is doing a very good job in the training data, but does a very poor job in the test set. Think about the student. This student is doing very well on the sample test, and then all of a sudden she is doing a very poor job on the real test. So what do you think about this situation? What you think is okay, she memorized the things, right? She didn't learn the things well, therefore she failed in the real test. So whenever we see a situation that the training numbers are very high, that means accuracy, sensitivity, whatsoever, right? They are very high, but in the test set those numbers are decreasing. It's a strong sign of overfitting. Okay. The third thing is it fails to generalize linear examples. Okay. So overfitting in the visuals. Okay. Like so far we've talked about the data set as if we have an Excel spreadsheet in front of us. Here we have the visuals. So before getting started, let's think about the regression. Remember in the regression we have these dots, right? What we were trying to do was we were trying to fit a line in such a way that the error between the dots and the line is minimized, right? That's why we call it what? Remember minimum squared error, right? That's what the concept is. So in support vector machines, again we have these. Let's just go back. All right. So in support vector machine, what is happening is that we have this thing, right? And then we have some circles here, right? Blue circles, and then we have some like dots here, right? And our job was to fit it, not to fit a line, but put support vectors, right? Remember, I had these support vectors that I was trying to maximize the distance in between the closest cases and those lines. That's what I was trying to do, right? So what is going to happen in the real situation is that, okay, our dots will look like this, okay? That's what the natural look of the visual, right? So if you want to go and fit a line here, what you're going to witness is that the error between your dots and the line is going to be a lot, right? Because it's not a well-fitting line, right? So this is the first case. So we call it underfitting. So when you think about this case, okay, the same dots as you can see, but what we're trying to do is we're fitting a line in a way that it's doing a perfect job. There is no error, right? But remember, this is a training data. These dots are the training samples. If we try to over adapt ourselves into this, and the real test data might be looking something like this, not the exact shape, right? So if you try to do the same exact here, then you will have a lot of errors. So training set will not be exactly the same with the test set. Test set might differ a bit from the training. Okay, therefore you should not be overfitting yourself in the training. So the ideal case is yes, you know, you're going to fit a line. This is a quadratic form of a line, right? This is not linear. So what you're going to do is that you have these dots here, okay, the blue dots, and you have this line in a way that you're trying to minimize the error between the dots and the line. The dots and the line, okay? But you're seeing that there is still some error, but you should be okay with it. Okay? If you try to minimize the error in the training, then again, you go to the over adapting or overfitting issue. So what you should do is you should do it in a way that, okay, you should be okay with some errors, because the sacrifice that you're doing here will be benefiting you. You will be benefiting a lot out of it when it comes to test set. Okay? So what matters is that the error that you make on the test set in your real prediction. This is only a training stage. So you should relax yourself a little bit and you should make some error. Okay, you should be okay with some errors so that in the test set, it can be generalizable. All right, that's what it means in the visuals. Same here. Here, let's say these are the reds are the sick patients and the blues are the healthy patients, right? In this one, you're underfitting, right? Because you're not doing a good job in, differentiating the patients. Here, you're doing a very reasonable job. You're still making some error, as you can see. There is still, like, when you fit the line here, this quadratic line, you are seeing that you have misclassified those sick patients as healthy patients. Okay, but it's okay. It's in a form that it can be easily generalizable. The third case is the overfitting. Okay, what you're doing is you're trying not to make any single mistake. You're over adapting yourself to the training data. But again, what you have is a very, very detailed, line here. Okay, very complicated line, and you cannot guarantee that the same line will work very well when we have the real test. Okay, real data might not look like this. That might be something similar. That might be something different. Okay, therefore you will fail you will fail in the real test. That means, okay, long story short, we gotta fit the line in a way that we should be okay with this, with some errors, so that my, error in the test set will be reasonable. How to detect it? Okay, this is the case. Which model to choose? Okay, assume that we have three models: SVM, CRT, and logistic regression. And when we look at the accuracy in the training set and the AUC and all, right, what we are witnessing is, okay, for the SVM model, the accuracy, sensitivity, specificity, and AUC values goes down a lot in the test set. In the training, it was high. In the test set, it's low. So it's a very good sign of an overfitting issue here. CRT is the same, but not as much. But there is still some overfitting here. When you look at the logistic regression model, the training and the test set results are pretty similar. Okay, there might be some difference, which is okay. So this is the only one that we do not have any overfitting issue, right? Among these three examples, the first two obviously are experiencing an overfitting issue just because there is a good, model in the training, but the model does not work in the test. That's what it means. All right. So, okay, overfitting again, how to detect and what happens when you have the model complexity, right? So model complexity again in most of the cases mean the high number of variables or features. Okay, that should scare you. Okay, high number of variables. So what happens is that, okay, this is our beginning point when there is no complexity. Okay, that means when we don't have any variables. So as we add variables, what will happen is that, okay, let's say now you started to analyze data and you want to use only one variable, one feature. What it will do is it will decrease the prediction error, right? This is, by the way, the blue line is representing the training error, and this orange line is representing the test error. What will happen when you use only one variable? Your training error will decrease, your test error will decrease. That means you will start to learn gradually. Okay, when you have two variables, okay, they will keep decreasing. So you're able to learn better when you have two features. When you have three, right, the error of the models will keep decreasing, and so on and so forth. So when you reach to a point, let's say when you have 20 variables, let's say the maximum number of variables is 50. Let us assume that we have 50 variables in total. So when you reach to 20, what will happen is that, up until 20, the error that you're making on the training set kept decreasing, and the test set as well. But after that, the overfitting issue will start to happen, right? What will happen is that the test error will start going up, and training set always will go down regardless. Okay, so over here what will happen is that even though you think that you're doing a very good job by just looking at the training data, in the actual situation, in the real situation, actually you started to do worse from this point on. Okay, this is the point where the overfitting, issue has started to happen. All right, that's why you should stop here and you should only pick 20 of these 50 variables in your model, and you should ignore the the other 30. Okay, only then, yes, your training error will not be minimized, and it's okay with it. What matters is the prediction. What matters is the test error, not the training. Okay, here the same example. This is the continuous, right? That's why we're talking about mean absolute error. Okay, it keeps decreasing until a point, and then the training error will keep still decrease will keep decreasing, but the test error, the cross validation, is actually test error. Okay, so that's, we kind of can use those terms interchangeably, which I will explain in the future videos. But at this point, just know it as the test. Okay, the test error. All right. What about the two-fifth cases? So when you have two-fifth cases, in the previous two slides we talked about the too many variables, the complexity, but now we're talking about two-fifth cases instead of too many variables. Okay, so this is the data set size. That means the number of the samples. Okay, number of samples. Okay, the testing error is the blue, training error is the green, and then that's where we are, we have the overfitting issue. So error. So when you have only one sample that you train yourself, right? The training error will be minimized, right? Because like your training error means you're training yourself on the training data, and you are testing yourself on the training data once again. That's what we call training error. Okay, so when you have only one case, one sample, what you're doing is you're learning, you're getting exposed to a case, and you're labeling it again. Or from the student, example, there's only one sample question, one question in the sample exam, and student is studying on that question and testing herself on the same question, which means the training, I mean, she will not be making mistake if there's only one question, right? But the test error will be very, very high. Okay, so as she keeps adding question in the training set data, right, or the sample test, what will happen is that the training error will potentially increase, right? But what will happen to test, since the student has started to learn the things better, the testing error will go down. Okay, let's say up until 50 question, it will kind of plateau. All right, so after a point, the amount of the questions that she solves from the sample test will not affect the testing error a lot. Okay, so that's what the analogy is. So data set size is important. The more data that we have is very good. The more number of samples that we have is the better our model will work. But after a point, it does contribute very, 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 minimally. All right, so it can, after a point it can be even ignored. That's what happens, right? So how to fix those? Okay, since it occurs when there is a complexity in the model, so what we need to do is we need to reduce the complexity of the data set. That means we need the feature selection, we need the variable selection, we need to cherry pick those variables that are useful for our prediction. Okay, that will not bring any type of complexity. Okay, and the model selection, some models are they are sensitive to the overfitting. What it means is that, okay, when there is a data set that can cause overfitting, these models are buying it. Okay, so I mean, when you look at the CRT decision trees and so on and so forth, okay, so if you add too many complex parameters, okay, when you play with the parameters in a way that those parameters tend to be an overfitting environment. So we need to select our models very carefully, and we need to play with the parameters very carefully in a way that we're not overfitting our things, right? And the k-fold cross validation, which I will be explaining in a separate video. Thank you very much for listening me, and hoping to see you guys in